Hi, welcome to my channel KP Engineering Drawing. In the last lecture, we have seen engineering scales in the types of scales, that is plane scale, diagonal scale, comparative scale, vernier scale and scale of parts. And we have seen two formulas, that is representative fraction and length of scale. And we have gone through units of measurements, that is metric system, so the conversions from kilometer to millimeter. So in this today's lecture, we'll see a problem based on plane scale. So before going to start the problem, please do like, share and subscribe my channel. So we'll see the problem. The problem is like this. Construct a scale of 1:40 to read meters and decimeters and long enough to measure up to 6 meters. Mark a distance of 4.7 meters on it. So this problem comes under plane scale. So plane scale, right? So in plane scale, generally, you need to calculate two things, that is representative fraction and length of scale. And before going to see that, we'll see a simple example, that is scale. So generally we have a scale here, a normal scale, right? So in this we have some conversions. See, this is centimeter scale. So 1 centimeter, 2, 3, 4 and 5 up to 15 centimeters. So this is the main scale. This is the main scale. And again we have millimeter scale also. So here this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 centimeter is equals to 10 millimeters. So generally plane scale consisting of two scales, that is main scale, number one is main scale, and two, its subscale. So this is main scale and its subscale. Okay, so now we are going to show a plane scale and we are going to mark 4.7 meters on it. So 4.7 meters, what is saying is asking us to mark 4.7 meters. So 4 meters and its conversion 4 meters. 1 meter is equals to what? 10 decimeters. So we need to mark 4 meters and 7 decimeters. So the main scale will be meter scale and subscale will be decimeter scale. Okay. So before going to construct the scale, first we need to find out representative fraction. RF. So in the problem, RF is directly given. RF is 1:40. 1:40. Right? And one more, it is length of scale. LS. So what is LS? LS is equals to RF into maximum length or maximum distance. Already we have RF, that is 1/40, and maximum distance in the problem is given as 6 meters. So you convert these meters into centimeters. So you go on convert it, that is 1/40 into 6 meters. 1 meter is equals to 10 decimeters, that is 10 decimeters. 1 decimeter is equals to 10 centimeters. So we have converted meter into centimeters. 6 meters, 10 decimeters, 10 centimeters. Okay. So the length of scale will be 15 centimeters. And always you remember that length of scale should be in centimeters only. That's why we are converting the maximum distance up to centimeters, right? And we have the conversions also, that is 1 meter is equal to 10 decimeters, right? So 1 meter is equal to 10 decimeter. 1 decimeter is equal to 10 centimeter. So that is 6 meters is equal to 10 decimeters, 10 centimeters. Totally we get length of scale as 15 centimeters. Now we need to draw the scale by using length of scale as 15 centimeters. So now draw a scale of LS is equal to 15 centimeters. So the height of the scale should be 10 mm, or sometimes we can take it as 5 mm also, but for more visibility we will take 10 mm as the height of the scale, right? So this is scale of LS is equal to 15 centimeters. Now divide this scale into 6 equal parts, because maximum distance is given as 6 meters. So divide this 15 centimeters scale into 6 equal parts. 6 equal parts. So this should be divided into 6 equal parts by line divide method. Line divide method. Line divide method. So for example, see, if you want to divide a 50 centimeter line, so we can directly draw 5 parts 10 centimeters, so 50. But here we have 15 centimeters and we have to divide that into 6 equal parts, so we cannot exactly divide that. That's why what we are going to do is we are using line divide method for dividing this length of scale 15 centimeters into 6 number of equal parts. So take a inclined line. Take a inclined line less than 45 degrees, okay, and now with the help of compass, you take any convenient radius. So we cannot say 10 mm, 15 mm, 20 mm, so we can take any convenient radius, right, as we like. So if I take this much also no problem, this also no problem, so I will take this much as a radius. So now from here, say this point is say A and point B, right? So from A you take some radius. I am taking some convenient radius like this, right? Now A has entered with this radius. You cut this inclined line, okay. Now with same radius, so no change in radius. With same radius again, say this is 1 dash, okay. 1 dash has radius center and this has radius. You cut one more point, okay. So with same radius again 3, again same radius 4, with same radius 5, with same radius 6. So here it is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. And always you remember that whenever you draw a scale, the main scale should be with H pencil, that is dark, and remaining everything is construction part. So definitely you have to draw that with light pencil, right? H pencil, 2H pencil, 3H pencil. Okay. So now we have divided this incline into 6 equal parts. Now with the help of your mini drafter, what we will do is, so we have 2 scales, right? So you fix the scale on point 6 dash and B, 6 dash and B, right? So others we can do the scale also. I'm showing here with scale, but generally we have to use mini drafter, right? Why? Because it is having 2 scales. If you fix this scale, right, and go on move by drawing the lines, so you'll get all parallel lines. You fix a drafter, right, and move it to the next point. We have drawn 6 dash and 6 dash and B, right? Now fix your drafter and move to the next point, that is 5 dash, and again move to the next point, it is 4 dash, and again next 3 dash, 2 dash, and finally 1 dash. So like this we'll get. So this is say 1, 2, 3, 4, 5 and 6. Okay. So we have divided 6 parts. Now right, you draw all vertical lines from these points. Say it is from here and 2, 3, 4, 5 and 6. Okay, so total 6 equal parts. Now you write it as 0, 1, 2, 3, 4 and 5 and 5. So this will become your main scale. So main scale is in, already said 4.7 meters we have to mark. So 4 is the main scale and this after decimal 7 is the subscale. So 4 is meter scale and 7 is the decimeter scale. So main scale and subscale. So we have drawn main scale by showing 6 meters. 1 meter, 2 meter, 3, 4, 5 and 6 meters. So you write here meters. So that the scale is meter scale. Meter. Right? Next, 1 meter is equals to 10 decimeters. So divide this 1 meter into 10 equal parts again. Okay. So same procedure, that is take a less than 45 degrees line, right, with the help of the compass, with any convenient radius. I will take a small radius, right, I'll take a small radius, okay, and I'll cut 10 parts from here. So 1, 2, 3, 4, 5, 6, 7, 8 with same radius, 8, 9 and finally 10. Right? Now you join all these points, say this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash and 10 dash. So join 10th point with 0, 10th point with 0, right? Draw a line. You fix your drafter again, okay, and move to the next point, that is we are fixing the drafter and we are moving to the next point, 9 dash, next 8 dash, next 7 dash, next 6 dash, next 5 dash, 4 dash, 3 dash, 2 dash and 1 dash. Right? So like this we have to divide into 10 equal parts. Now to the main scale, just I will draw horizontal line, right? Here I have drawn 1, 2, 3, right? So now you project all these points, 1 to 10 points are there, no? So all these points vertically downwards onto this line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So here 0, 2, 4, 6, 8 and 10. Okay. So divide this into equal parts, 10 equal parts. Okay. So this is your decimeter scale. This is your decimeter scale. So write here it is decimeter meter, right? And already RF is given, it is RF is 1:40. So write that in the middle of the scale. RF is equals to 1:40. So this is now main scale meter scale and its subscale decimeter. Okay. Now we have to mark 4.7 meters, that is 4 meters and 7 decimeters. So we have 4 meters here, 4 meters and 7 decimeters. So 7 decimeters. 7 decimeters. So this will become your 4.7. Okay. So draw 2 arrowheads. Here is 1 and 2. Right. So this is 4.7 meters. 4.7 meters. You write in the middle of the dimension line. Okay. So this is the problem. This is the problem. Very simple. So what we have done? Yes, we have taken 15 centimeters line, right? And we have formed a scale, and the height of the scale is 10 mm. Otherwise, we can take 5 mm or 20 mm, no problem. Okay. Afterwards, you divide this line into 6 equal parts by line divide method. That is a inclined line less than 45 degrees with some convenient radius. Any radius, we have taken that radius and we have cut this inclined line into 6 parts: 1 dash, 2 dash, 3 dash, 4 dash, 5 and 6 dash. Now join 6th point and last point with the help of your drafter. Fix it and draw a line, and from there you move on the drafter so that you will get all parallel lines at these points 4, 3, 2, 1, 0. Okay. So now we have drawn vertical lines, right? So we got 1 meter, 2, 3, 4, 5, 6 meters. This is main scale. We have shown main scale. And again, subscale is 1 meter is equal to 10 decimeters. So 1 meter we have divided into 10 parts. That is 10 decimeters. We have shown 10 decimeters here. Okay. So 10 decimeters. Right here decimeter. And in the middle write RF. Now marking the distance, that is 4.7. 4 meters, 7 decimeters. So with this, our problem is completed. Okay. In the next class, we will see one more problem. So please do like, share and subscribe my channel. Thank you.